is John Landry. I'm been with Sumitomo for about a year, and but been a gearbox guy for about 37. So buying efficient right-angle gearboxes is critical. A lot of people like to use them because they're inexpensive. You can get a high ratio and in a very low cost package. The problem is that they can be very inefficient. The higher you go in the ratio, the less efficient it gets. So when a gearbox is inefficient, that means that it's going to create a lot of heat. And then because there's a lot of sliding action in there, the motor's going to have to work harder. So then your motor's going to be creating heat, which reduces the motor life. And then because of the heat from the gearbox, you're creating oil pressure, so you're going to get leakage. And essentially, especially if you're in a cold environment, now you've got to take that heat, which can be as high as 150 degrees Fahrenheit, and have to get that down to about a 40-degree ambient temperature. So it's then energy not only to run it, but then energy to take the heat out of the gearbox. And so a lot of times people use gear motors because they are the most dynamic and cost effective. And the other thing to be aware of is that most of the inline gearboxes are all fairly even on their efficiency. So the energy requirements is typically only for the right angle gearboxes. Another thing that comes up is capital equipment, and a lot of people are selling capital equipment on a very low cost, and it's a very competitive environment for the OEMs. And one thing that more and more end users are making statements on is sustainability and keeping their energy or getting energy reduction or being carbon neutral by 2030 or later. So selling on operating costs, what it takes to run your machine, at least it raises the questions of, okay, what is the energy use or energy requirement of this machine, and how does it compare to other competitors? So it can be a selling feature for you equipment builders. And what we do at Sumitomo is we educate people's sales teams in order to be able to sell on those operating costs and make that part of the selling procedure. And then as far as minimizing maintenance, including maintenance contracts, which I believe a lot of people do already, can help kind of prevent things from going awry. And because the plants don't have a lot of people that know as much as they used to, a lot of people are retiring, younger people coming in, a lot of turnover, maintenance contracts are very important. So as far as predictive maintenance, there's things that are monitored. Vibration and temperature are key. And the vibration requires some special equipment. It can be very difficult. This is shows kind of a picture on the right-hand side. It's difficult to understand what peak there is attributed to what component in the machine. Is it a bearing? Is it a gear tooth, or whatever? But there are educated people that know how to read this data, interpret it. And because vibrations can be happening in the plant already, you should take those baseline values after you install a machine, because there will be some vibrations that show up that would be a lot different than when you're doing the runoff on your machine in the plant. Temperature is a very good monitor for the status of a component, whether it's a motor or a gearbox or a bearing. It's easy to capture. There's a lot of different methods of capturing it. And there's temperature guns. You can put sensors on your machines to capture it. Sometimes the motor data. Different motor manufacturers have that come up in their control software, and you can kind of set baselines or set limits so that you then get alarms when the temperature is getting too high. Now, out in the field and for general conveyors and for users, amp draw is a very strong also indication of what's happening in the system. If the motor is having to draw more energy or amperage, then it's probably seeing more friction in the system due to bearings wearing out, gears wearing out, etc. So there are handheld devices that you can, kind of clamp onto a motor and get the amperage data. You do need the motor tag in order to kind of understand what percentage of the load there is. But then a lot of systems have a VFD already, and you can also get that from the VFD as far as the amp load goes. Regardless of what you're monitoring, consistency of when you get the data is key, because you want to make sure you're comparing apples to apples, and whether you're doing it every day, once a week, or whatever, try to get that data at the same time that you're running the same line speed, the right product or the same product, or are you capturing startup data, etc. So consistency of when you get that each time, make sure that you're comparing apples to apples is critical. So the systems that are coming out now are full-blown systems. Some people are, taking the whole system and monitoring everything, and a lot of it is vibration monitoring. But there are smaller and simpler systems on the market. Typically, these condition monitoring systems, once they're set up, the companies will then say to analyze the data. It may be a monthly fee, which can be a high cost. Some people don't require a fee, but make sure you ask about that when you're putting a system in as an end user, or make sure that's part of the conversation if you're selling a machine. So there is some data that people can capture on machines in the controls. Some OEMs even put it on their HMI screen, so you can get that and people can see that on a daily basis. But if you're an end user trying to get into it, the idea would be to start small and get a smaller system. Don't try to have so many, have 20 different axes you're controlling, but look at that, the bottlenecks or those critical access that could shut your plant down, or some very old units that you don't know that eventually are going to have to be replaced. So try it out on a couple of axes, get the people to understand the process, make sure you got a couple of people are trained on that in the end user or at the user level in the plant, and because a lot of times if it's only one person, that guy leaves, or if that person is sick that day, then you're going to be running without a system or analysis. So the last slide here is gearbox tips. Why is a gearbox hot? It's typically the lower ratio gearboxes are running hot because the output shaft is running faster, and so that generates more heat. And then the gearbox design, as I stated earlier, the right angle worm gearboxes have a lot of sliding motion, and so they are inefficient and will run hot. But mostly the inline gearboxes all have about the same efficiency. What fails first is the input seal. The input seal is going is the highest speed in the gearbox, and it typically is the one that generates the most heat, and then consequently fails first. I've got a picture of a gearbox below, or a motor below a gearbox with a belt system going up to it. But a lot of times that motor, instead of having a belt go up to the gearbox, will be vertical with the shaft up. And in those mounting orientations, as the input seal is the first to fail, that that motor will just get flooded with oil, and now you've kind of failed both components in the in one shot. So try to put the motor and gearbox horizontal, and that requires the least amount of oil, so you have the least amount of pressure in there. And then as a general note, sometimes things need to be greased on a machine, and many maintenance people can think that more is better, but what happens when you put too much grease is that things tend to, the grease tends to restrict the rotation of the balls and the bearings and the gears, and so it then causes more damage than just having the proper amount. And got to look at the manuals on that, but that's very critical. Is greasing is do less pumps of the grease gun than more.